When we look up at the moon on a quiet night, we see more than just a glowing orb in the sky. For decades, the moon has represented the ultimate frontier, a symbol of human ambition, rivalry, and cooperation. Today, a fascinating story is unfolding on its surface. A story of two nations, Russia and China, each carrying their own legacy and aspirations, converging on a shared goal. But what exactly are the strengths, challenges, and ambitions that define their race to conquer the moon? And how are they working together to turn a centuries-old dream into reality? Let's dive into the heart of a technological rivalry, a tale of setbacks, breakthroughs, and a vision for the future. To decode this problem, watch until the end. A surprise awaits you. Subscribe to the channel now so you don't miss out on valuable knowledge, and join me on the journey of independent scientists. The first question we must ask is, who blazed the trail to the moon? The answer goes back to the era of the Soviet Union. In the early days of the space race, the Soviet Union stunned the world. They launched Sputnik 1, the very first artificial satellite, in 1957. Not long after, Yuri Gagarin became the first human to journey into space. But their ambitions didn't stop there. In 1966, Luna 9 became the first spacecraft to achieve a soft landing on the moon's surface, a feat that opened new realms of possibility. Throughout the 1960s and 70s, the Soviet Luna program set a series of impressive milestones. Robotic rovers such as Lunokhod 1 and 2 traversed the lunar terrain, collecting invaluable data. Luna 16, 20, and 24 further demonstrated Soviet prowess by retrieving samples from the moon and bringing them safely back to Earth. These missions not only expanded our understanding of lunar science, but also solidified the Soviet Union's place as a pioneer in space exploration. Yet for Russia, the legacy of lunar exploration is tinged with both glory and frustration. After the 1970s, their lunar program entered a prolonged hiatus. Decades passed, with dreams of returning to the moon fading into the background. Until recently, in 2023, the Luna 25 mission was launched with high hopes. The aim was bold: to land on the moon's south pole, a region of scientific intrigue and potential resources. But the mission ended in disappointment when the lander crashed during descent, highlighting the challenges of reviving a dormant program and the unforgiving nature of lunar exploration. While Russia was reflecting on its storied past and struggling to regain momentum, another nation was quietly rising to prominence. China entered the lunar arena much later, but did so with a clear, methodical strategy. The Chang'e program, named after the mythical moon goddess, began in 2007, structured around three key stages: orbiting, landing, and returning samples. Each mission built upon the last, methodically advancing China's capabilities. Successes came swiftly. Chang'e 3 achieved a soft landing and deployed the U-2 rover, marking China's first steps on the lunar surface. But it was Chang'e 4 that truly captured the world's attention. By landing on the far side of the moon, the mysterious dark side no nation had explored before, China proved its technological mettle. This feat required the deployment of a relay satellite, Queqiao, which bridged the communication gap between the far side of the moon and Earth. The ingenuity and precision of this mission demonstrated how quickly China had mastered complex space technology. The momentum didn't stop there. Chang'e 5 and 6 delivered another breakthrough: the successful retrieval of lunar samples, including from the moon's far side. These missions showcased advanced robotics, automated drilling, and sample return technology, placing China at the forefront of modern lunar science. So what sets Russia and China apart in their approach to lunar conquest? At the heart of this story lie their respective technological strengths. Russia's legacy is built on the reliability of its Soyuz rockets, proven over decades of service. These workhorses have been the backbone of countless missions. But as the demands of deep space exploration increase, Russia is racing to develop newer, more powerful launch vehicles to stay competitive. In contrast, China's Long March rocket family, especially the Long March 5, has rapidly become a force to be reckoned with. Designed to carry heavy payloads and support increasingly complex missions, These rockets symbolize China's commitment to expanding its reach beyond Earth orbit. As they develop even more powerful variants, China is laying the groundwork for future crewed missions and long-term lunar operations. Landing and operating on the moon's surface is a formidable challenge, demanding precision, resilience, and adaptability. Russia's Luna 25, though ultimately unsuccessful, embodied decades of Soviet expertise, with a compact, lightweight design tailored for the moon's treacherous South Pole. Despite the setback, Russia's experience with robotic landers and rovers remains a valuable asset. Meanwhile, China's Chang'e missions have set new standards in soft landing accuracy, rover deployment, and scientific instrumentation. By safely landing on varied and hazardous terrains, including the far side, China has proven its mastery over automated exploration and sample collection. Communication is another critical factor, especially when operating on the moon's far side, where direct contact with Earth is impossible. Russia's deep space network, inherited from the Soviet era, is robust but in need of modernization. China, on the other hand, has developed its own deep space communications infrastructure, punctuated by the innovative Queqiao relay satellite. This technological leap has given China a unique advantage in accessing previously unreachable lunar regions. But perhaps the most intriguing development is not in their rivalry, but in their alliance. Facing the immense technical and financial demands of sustained lunar exploration, Russia and China have chosen to collaborate on an ambitious project, the International Lunar Research Station, or ILRS. This joint venture aims to establish a permanent research outpost at the moon's south pole, an area believed to harbor water ice and enjoy stable sunlight, making it ideal for long-term habitation and scientific study. Within this partnership, each nation brings distinct strengths. Russia is poised to contribute its expertise in nuclear space power, with plans to develop a lunar nuclear reactor by 2035. This technology could provide a reliable energy source for lunar operations, enabling continuous research and even future human presence. China, meanwhile, will leverage its advanced landers, rovers, and automated sampling systems to build and support the station. The vision for the ILRS is bold: to create an automated and eventually crewed base that will serve as a springboard for deeper space exploration. It will be a platform for scientific discovery, technological innovation, and, most importantly, international cooperation. So, as we compare Russia and China's journey to the moon, we see a tapestry woven from contrasting legacies, unique technological strengths, and shared ambitions. Russia, the trailblazer of the past, is striving to reclaim its place among the stars, bolstered by experience and a renewed spirit of innovation. China, the determined newcomer, has rapidly ascended to the cutting edge, setting new benchmarks in lunar exploration. Their partnership on the International Lunar Research Station marks a turning point, not just for lunar science, but for humanity's collective future in space. It is a testament to what can be achieved when tradition meets innovation and when competition gives way to collaboration. If you've watched this far, congratulations! You are truly a passionate scientific explorer, always persisting and conquering every challenge. Let's subscribe to the channel so we can keep on discovering together. The race to the moon is far from over. It is evolving, shaped by new challenges and opportunities. As Russia and China join forces, they invite the world to witness not just a contest of technology, but a shared journey toward the unknown. A journey that, in the end, belongs to all of us.